In this video, I'm going to show you how to graph a sine function. I came up with 3 basic steps. These are kind of shortcuts to help you graph it pretty easily. It doesn't really go too far in depth, so I'd encourage you to kind of explore more about sine functions rather than think that this video is going to be everything you need to know. But it will be a nice little shortcut and an easy way to get the graph of a sine function. So in general, if you can identify the amplitude and the period, and then find and label what I call 5 key points on your graph, and then connect those points and draw your graph, you'll be able to graph a sine function. So we'll go through these steps and we'll do some examples here. So in general, a sine function will be in this form. You got the function name. There might be a number in front of your function. If it's not there, it's going to be implied that it's 1. But otherwise, whatever number is in front of your function will be the a value. And whatever number is in front of this x is going to be a b value. And we're going to use this a and b in equations to help us simplify things like period and amplitude. And if the b value is not there, again, it's implied that it's 1. That's the value. So if we look at an example of a sine function, the easiest one would be just sine of x. So in this case, the a value is implied that it's 1, and the b value is implied that it's also 1. Alright, so when we evaluate a sine function, what we're doing is we're taking an angle measurement, either in degrees or radians. I'm going to use radians today. And we're going to take the sine of that angle measurement. The output is going to be a coordinate, a y coordinate specifically, because we're doing sine functions. And so I've got a little xy table here. Inputs are going to be angle measurements, and my output is going to be a y coordinate, either on a coordinate plane, or we're going to see what's called a rectangular coordinate plane to graph these functions. So the first thing I'm going to do is kind of fill out my xy table here. If I have a 0, an angle measuring 0, if I plug that in, the sine of 0 is 0. That's going to be one of my 5 key points right there. The other values, I'm going to need to first figure out my period and my amplitude in order to finish my xy table. The period is going to be the length of the function. It's a full cycle. So if you think about going all the way around your unit circle, that is 1 period. But periods of various sine functions are going to change. It won't always be 360 degrees or 2 pi for a full cycle. So how we establish what the period is by evaluating this function, or this equation right here. It's always 2 pi over b for sine. It's also the same for cosine, and we'll do that in the next video. So if you can find your b value and plug it into this equation, you can find the period length. So the b value of this function is just 1. So 2 pi over 1 just simplifies to 2 pi. So I know that my full cycle is going to be 2 pi, and that would be normal on our unit circle. So if I know my angle measurement is 2 pi and I plug it in, the sine of 2 pi is going to be 0 as well. And you can either evaluate that based on your unit circle knowledge, or you can actually plug it into a calculator. If your calculator is in radian mode and you type in the sine of 2 pi, it should give you 0. Same thing if you type in sine of 0, it should give you 0, as long as you're in radian mode. Alright, so we got the period length. So what I'm going to do is I'm going to go down to my graph, and I know that at the end of my graph I'm going to end at 2 pi. That's going to be the end of my cycle. or the end of the pattern of my graph. Let's come up with some other values here. The amplitude is always going to be the A value, and the amplitude is the height of my graph. Amplitude is going to be the maximum. So I look for my A value, that's the value in front of sine, that's implied that it's 1 here. So I know that my amplitude is going to be 1. And so that would be the maximum of my graph. Oops. So this value, the height of my graph is going to be positive 1. And now I also know that would be the maximum. I also know my minimum, because the minimum is just the minimum, sorry. Graph is getting all crazy. The minimum is just going to be the opposite of this value, so I know it's going to be negative 1. And so now I actually know the possible y values, which would be the range of my graph, possible y values. The range is going to go at the bottom, negative 1. It's not going to go any lower than that. And the top is going to be positive 1. It's not going to go any higher than that. And I'm talking about y values for range. So possible y values are going to be in between negative 1 and 1. And so I can talk about the range in inequality form here. It's in between negative 1 and positive 1. And it's also going to include those values. So that's why I got the or equal. Alright, so I got my range, I've got my period length. The last thing to do is just to fill in the rest of the values in my graph or on my XY table. I have my start here. It's going to start at 0, and I know it's going to end at 2 pi. And so I need 3 more values to get my 5 key points. I already have 2 of them here. The next key point is always going to be a fourth of my period. So if I multiply my period by 1/4, that would be 2/4 pi, which would reduce to a half pi. So a quarter length of my graph is only going to be a half a pi. So down here on my graph I can put that at the quarter spot. The next spot is going to be half of my graph. That's exactly in the middle. And so if I take a half of my period length, I just get 1 pi. So on my graph I could fill out 1 pi there at that location. And then the last key point is going to be 3/4 of my period, which would be 6/4 or 3/2 pi, 3 pi over 2. So those are my 5 key points. I got the start, which for sine graphs will always be 0. I have the end, which is always my period length, and then I have a quarter of my period, a half of my period, and 3/4 of my period for my 5 key points. Let's figure out what the y value is going to be for each of these. If I plug it in, this is going to be my input right here. So if I take the sine of pi over 2, I should get 1. Now if I take the sine of pi, I should get 0. And if I take the sine of 3/2 pi, I should get negative 1. So there's my 5 key points. So I'm going to plot them on my graph. At pi over 2, I get an output of 1. Well, that ends up being the maximum of my graph. So if I start at 0, every time I graph a sine function, I'm going to start at 0, and the next spot, the quarter of my period, is always going to be the maximum spot. Then if I plug in pi, I get 0 again. And if I plug in 3 pi over 2, I forgot to put that on the graph. If I plug that in, I get negative 1, which is the minimum of my graph. And then I get 2 pi, I plug that in, I get an output of 0. So this ends up being the shape of a sine graph. It's a nice little curve, and it will always be the shape of a sine graph. This is called the sine curve. And the pattern will always be the same. It will always start at 0. At a quarter of your period, it will always be at the maximum. At half of your period, it will always be 0 again. And at 3/4 of your period, it will always be at the minimum. And it will always end at 0 again. So this pattern holds up every single time. And that's why I like to use this as a nice little cheat and a shortcut to graphing sine functions, because I always know that if I can get my 5 key points, 0, a quarter of my period, half of my period, 3/4 of my period, and my full period, I can just plug these points in. I don't even have to evaluate my XY table. I always do 0, maximum, 0, minimum, and full period. So let's take that pattern and let's apply it to a whole new graph and see if it works out. So this time I'm going to take the function 3 times the sine of 2x. So I need to find my amplitude. That's always the a value, the number in front of sine. So that's 3. I'm going to take the period, which is always 2 pi over b. And my b value is now 2. So 2 pi over 2 reduces to just pi. So my period length is 1 pi. I can then start to fill out my graph here. Here are my 5 key points. I got 0, and I got my period length. Let's figure out the y-axis real quick. I know that the maximum is my amplitude, 3. So the minimum must be the opposite of that, -3. 0 is always going to be in the middle. So I know my range is going to go from -3 up to +3. Now I just need these last 3 key points. This is going to be a quarter of my period. So a quarter of 1 pi is 1/4 pi. Half of pi is half of pi. And 3/4 of pi is 3 pi over 4. And then I know that my pattern is always going to be 0, maximum, 0, minimum, and 0 or full period length. And there is approximately the shape of my graph. So it's really nice and easy once you get these little steps down. It makes graphing sine functions really quick and easy. Let's do one more. Let's see if I can get down here. There we go. This time 2 times the sine of pi over 2x. So let's find the amplitude. Amplitude is going to be 2, so I know that my maximum is going to be 2 and my minimum is going to be -2. Let's figure out the period length. 2 pi over b. So this time b is pi over 2. So now I got to remember how to divide fractions. I need to multiply by the reciprocal. So I'm flipping and multiplying. This time the pi's will reduce, and so my period length is 4. So I put the period, full cycle period at the end of my graph. There's 4. I'm going to take a quarter of 4, which is just 1, half of 4, which is 2, and 3/4 of 4, which is 3. I know that my sine graph is going to start at 0. A quarter of my period is the maximum. Half of my period is 0 again. 3/4 of my period is the minimum. And then back up to 0 for my full period. And connect the dots. And there's my nice little sine curve. Alright, so good luck following those steps. Hopefully you'll find that graphing sine functions is fairly easy once you get the hang of it. And in the next video we'll be graphing cosine functions, which is pretty similar.